Today, I'm making a toxic invisible gas on purpose. The gas is nitric oxide, NO, colourless, reactive, and absolutely not something you want to breathe. To grasp why nitric oxide is so interesting, we must go back to the 1700s. In 1772, Joseph Priestley, the man who 2 years later would discover oxygen, reacted nitric acid with various metals and made a new gas he called nitrous air. He noticed it didn't support life, reacted strangely with ordinary air, and it could change in contact with plants and metals. He collected it over water in glass jars and wrote up his various experiments in his work, Experiments and Observations on Different Kinds of Air. Over the next century or so, chemists worked out that these different airs were actually compounds of nitrogen and oxygen. Nitric oxide became just one member of a whole family: nitric oxide, nitrogen dioxide, nitrous oxide, and so on. It shifted from mysterious air to a well-defined molecule. In this video, I'm going to recreate a modern version of Priestley's experiment. To a large 3-necked flask, I add some copper and a stirrer bar. Next, I add 2 adapters to the left and the right sides of the flask, followed by a dropping funnel, argon inlet at the middle neck, and gas outlet on the left neck. The gas outlet will run through tubing into a water-filled gas jar where nitric oxide is collected. All glass joints are greased and adapters clipped to ensure an airtight vessel. Before I start, I gently flush argon through the flask. That pushes out most of the air, so when I generate the gas, it isn't immediately reacting with oxygen. The receiving gas jar is filled with water, inverted in a bucket with the water in, before being clamped securely. I then run the gas outlet tube from the reaction vessel into the jar, so any gas I make will displace the water and I can see how much gas I've collected. Finally, I fill the dropping funnel with 30% nitric acid and cut off the argon. And now everything is ready, we can start the reaction. A classic way to make nitric oxide is to react copper metal with dilute nitric acid. If you use concentrated nitric acid, you tend to get nitrogen dioxide gas straight away. With a suitably dilute solution, the main gas you generate is exclusively NO. In simple terms, here's what's going on. Copper metal is oxidized to copper 2, forming copper 2 nitrate in solution. Nitrate ions from the acid are reduced to nitric oxide, NO. Water is produced and the NO leaves the solution as the gas. As soon as I open the dropping funnel, the copper starts dissolving and the solution starts turning greenish or blue-green as copper nitrate forms. Bubbles appear and rise through the liquid, and this is the gas being generated, and I can start to see the water in my gas jar being displaced. What was worrying at this point, however, was that I have what I like to call a no-no flask. The gas was clearly nitrogen dioxide, not the nitric oxide that I wanted, hence no NO. Anyway, strangely, on inspection, the gas bubbling through the gas jar was colourless. I figured that what was happening was that the nitric oxide was being made, but NO2 formed as it reacted with a trace amount of oxygen in the flask, and as it bubbled through the gas jar, the water was able to dissolve the NO2, leaving me with hopefully relatively pure nitric oxide gas.
Say my name.
So now on the left I have my collected nitric oxide gas, and on the right I have some oxygen which I have placed in a gas jar. So now is for the true test to see if we have successfully made nitric oxide. As mentioned previously, nitric oxide combines with oxygen to form nitrogen dioxide, which is a brown reddish gas. So we should start to see a brown gas form around now. As beautiful as this reaction is, if I had inhaled the contents of the jar, I would almost certainly be dead.